students, welcome to YouTube channel of Akshar Education. In this video we are going to discuss theorem number 10.1. Here the logical theorem is there. Here we have to prove the tangent at any point of circle is perpendicular to the radius through the point of contact. The tangent at any point of circle is perpendicular to the radius through the point of contact. That means if a circle is given and if we draw the tangent to a circle, then tangent will be perpendicular to the radius. It will be perpendicular to the radius through the point of contact. The radius drawn through the point of contact. So the tangent and radius both will be perpendicular to each other. Clear? That we have to prove. Circle is given. If we draw the tangent to a circle, then the tangent will be perpendicular to the radius through the point of contact. That means we have to consider radius through the point of contact, because we can draw so many radius in this circle, but we have to consider the radius at the point of contact. So this radius and tangent are perpendicular to each other. That we have to prove. So here given, what we are given? We are given one circle with center O. Circle with center O is given and its tangent AB is given. Circle with center O and tangent AB is given. So first you have to write the given statement. In circle with center O, AB is, this line AB is tangent to this circle and this point P is point of contact. What is point of contact? It's a common point between line, or you can say common point between tangent and circle. So tangent AB with point of contact P. This is given. Then what you have to prove? We have to prove that tangent AB is perpendicular to radius through this point of contact. So line AB is perpendicular to OP. That we have to prove. This line AB, tangent AB is perpendicular to radius OP. That we have to prove. Done? Now construction. To prove this, what we are doing? We are taking one point Q on line AB except the point P. That means we have to consider one point Q on line AB except this point P. Point P is the point of contact. तो आप लाइन AB पर पॉइंट P के अलावा कोई भी एक पॉइंट Q ले लो. So here we have considered point Q and join this point Q with the center. So we are getting line segment OQ, and that line segment OQ will intersect our circle at this point R. Clear? So here OP is the radius through the point of contact and OR is the radius of circle. Done? So this is construction. Now proof of this theorem. So how can we prove that this line OP is perpendicular to AB? So for that we have to consider the concept of shortest distance. Concept of shortest distance of a point from the line. So what is that concept? The concept of shortest distance of a point from the line says that, for example, this is line AB and this is point P. If you want to find the distance of this point P from this line AB, you have to draw one perpendicular to this line AB. So that perpendicular will give the distance of this point P from this line AB, because you can find the so many distance of this point P from this line, but you have to consider the shortest distance. The distance between any line and point is nothing but the shortest distance between them, and that shortest distance can be obtained by drawing perpendicular from that point to the line. Done? So this is the shortest distance concept that we are using over here. Let's check it. So here in our construction we have considered one point Q on line AB except the point P. Here it can be easily visible. Point Q on line AB, and that point Q can be any point on line AB except this point. Point P and point Q cannot be coincide, है ना? Point Q point P के ऊपर नहीं होना चाहिए. आप ये जो लाइन है, लाइन के ऊपर इनफिनिट पॉइंट है, उसमें से आप कोई भी एक पॉइंट ले लो, लेकिन आपको ये पॉइंट P नहीं लेना है. So let us now consider one point Q on line AB except the point P. So Q lies on line AB and Here we can see that this point Q lies outside the circle. Point Q lies on the outside the circle. So here we can see that this OQ intersect OB, OQ intersect the circle at this point R. So this point Q lies in the exterior part of the circle. So it's clearly seen that OQ is greater than OP, or we can say OQ is greater than OR. We will prove that OQ is greater than OP, but for that here we can say that OQ is greater than OR, or we can say OR is less than OQ. Why? Because OR is the part of OQ. So part is always less than the whole. Whole is OQ and OR its part. So part is always less than the whole. So here OR is less than OQ. OR is less than OQ. And here this OR and OP both are radii of the same circle. This OR and OP are the radii of same circle. So radii of same circle are equal. So here we can replace this OR with OP. Here we can replace this OR with OP. So now we can say that this OP is the distance of the point of contact from the origin. This OP is always less than OQ. Done? OP is always less than OQ. पूरा concept यहाँ पर है. OP is less than OQ. So what is Q? Q is any point on line. You can take point Q over here, over here, over here, or आप कोई भी point ले लो. Always OP will be less than OQ. So we can say that OP is the shortest distance. है ना? OP will be always shorter than any line segment joining point O at any point AB other than P. This line segment OP will always remain shorter than any line segment joining point on line segment AB. OP will be always shorter than any line segment joining the center O to the any point on line AB except this point P. So OP will always remain shorter. That is, OP is the shortest distance. OP is the shortest distance between center to the point. OP is the shortest distance, and shortest distance from the point to the line is always perpendicular. Shortest distance concept. So it will always perpendicular to the line, and therefore we can say that OP is perpendicular to AB. No mathematical calculation is there. It's a purely logical proof. Done? So you have to prove this theorem by using these statements. Clear, students? So pause the video and note it.